So we'll do the partial fraction of this. So first thing would be to multiply both sides of this equation by the denominator, right? So 3x minus 7 times 2x plus 3. So let's use a different color so that you can see. 3x minus 7 times 2x plus 3. 3x minus 7 times 2x plus 3. 3x minus 7 times 2x plus 3. So on the left, this cancel out. That gives you 2x plus 1 is equal to, on the right, 3x minus 7, 3x minus 7 cancel here. That leaves you with a times 2x plus 3 plus 2x plus 3, 2x plus 3 cancel out. That gives you b times 3x plus, minus 7. Now we just need to simplify it. 2x plus 1 is equal to, using the distributive property, we get 2a times x plus 3a plus 3b times x minus 7b. All right, so 2x plus 1 is equal to, now combine the terms that have x's in them. So it's going to be 2a plus 3b times x plus 3a minus 7b. Now, this is a polynomial equation, so the coefficients must be the same, okay? So that means coefficient of x on the left, which is 2, must be equal to coefficient of x on the right, which is 2a plus 3b. So we need to write 2a plus 3b is equal to 2. Similarly, constant on the left must be equal to constant on the right, which is 3a minus 7b is equal to 1. Now you can solve it in any way you want. I would multiply the top equation by -3 and bottom equation by 2. That would result in -6a minus 9b is equal to -6. Then 6a minus 14b is equal to 2. Then I can add these two to get -23b is equal to -4, or b is equal to 4 over 23. Now that you found b, you can go ahead and find a easily. A is going to be what? So we have one equation, 2a plus 3b is equal to 2. 2a plus 3b is equal to 2, or 2a is equal to 2 minus 3b, or a is equal to 1/2 times 2 minus 3b. So I can go ahead and solve it. 1/2 times 2 minus 3 times b. B is 4 over 23. Okay, this is going to be a is equal to 1/2 times 2 is just 1. Okay, minus 3 times 4 is 12. In the denominator, 2 times 23 is 46. So a is equal to 1 is 46 over 46, right? I'm making the denominator same. 12 over 46. So a is equal to 46 minus 12 is, by the way, 34 over 46, right? So 2 goes into 34 17 times, 2 goes into 46 23 times, or A is equal to 17 over 23. And B is equal to 4 over 23. And that is how you find the solution to this problem. Okay. Is it clear, everybody? Now your partial fraction is going to be, by the way, in case if you're wondering, is going to be 2x plus 1 over 3x minus 7 times 2x plus 3 is equal to, A is 17 over 23, right? It's going to be 17 over 23 divided by 3x minus 7 plus B is 4 over 23 divided by 2x plus 3. And that is how you do this problem. Now, one thing I kind of want to bring to your attention, instead of doing this, multiplying the equations by constants to eliminate A, right? We could just use Gauss-Jordan here, okay? So let's see, what is the equation? 2A plus 3B is equal to 2. 2A, oops. 2A plus 3B equal to 2, and 3A minus 7B equal to 1. Let's see, what is the easiest way I can rewrite it without losing it. Okay, I'll just do the old-fashioned way. 2A plus 3B is equal to 2, and 3A minus 7B is equal to 1. Okay. So 2A plus 3B is equal to 2. 2A plus 3B is equal to 2, and 3A minus 7B is equal to 1. Now I'm going to go ahead and use the Gauss-Jordan method to solve the same set of equations. All right. Use the Gauss-Jordan method to solve the same set of equations. So write the augmented matrix. Okay, it's going to be 2, 3, and 2, right? So that's your X column, Y column, and the constant. Then 3, negative 7, and 1. 3, negative 7, and 1. There's the augmented matrix. Now we're going to put a vertical line here. Remember, our objective is to convert this into what we call row echelon form. I mean, reduced row echelon form, which would be something like this: 1, 0, 0, 1, vertical line, A, B, some constants, A and B. Okay. Now, what we need to do is this. We need to apply the row operations and bring it to reduced row echelon form. Bring it to reduced row echelon form. Remember, we need to make the top left corner a 1. Hopefully you remember the rules. There are 3 rules. You can multiply any row by any non-zero constant. Okay, rule number 1, you can multiply a row by a non-zero constant. Okay. Number 2, switch any 2 rows. Switch any 2 rows. And number 3, multiply any row by a, I'll keep it non-zero. In this case, if you multiply by 0, it becomes trivial, okay? By non-zero constant and add the result to another row. Okay, these are the 3 row operations you can perform. So what do you guys say? How do I make the top left corner 1? What is your suggestion? What do you think, guys? How would I make the top left corner a 1?
You multiply it by a half.
Exactly. You multiply the top row or the first row by 1/2. Exactly. So 1/2 times row 1 becomes my new row 1. Don't write equal. Use arrow sign. It's not equal. You take the top row and you multiply it by 1/2, and this becomes your new top row or first row. Guys, keep an eye on my calculations because I tend to make a lot of mistakes on this Gauss-Jordan method. So 1/2 times 2 is 1. 1/2 times 3 is 3/2. Then 1/2 times 2 is 1. And I don't do anything to the second row. 3, -7, and 1. Good. So next is gonna be this. I gotta make this 3 a 0. So what do you think should be my operation here, row operation?
Try and multiply the top row by -2 and then add it to the bottom.
You mean -3, right?
But you want it to be 0? Yeah, -2.
So exactly. Multiply the first row by -3. So -3 times row 1. Add the result to row 2. And this becomes your new row 2. What I'm going to do, I'm going to do this calculation on the side so that you can see it. So my row 1 is 1, 3/2, and 1. I'm going to take this row and multiply it by -3. So -3 times 1 is -3. -3 times 3/2 is -9/2. -3 times 1 is -3. Then I take that result, this result, and add it to the existing second row, which is 3, -7, and 1. If I add these 2 rows, -3 plus 3 is 0. -9/2 plus 7/2, what is it? -9/2 minus 7. 7 is 14/2 is equal to -23/2. This is going to be -23/2. -2, 3 plus 1 is -2. So these becomes your new row 2, okay? So the first row, we don't touch it, 3/2, 1. And the second row becomes 0, -23/2, and -2. Good. So I made the first column, the top leftmost entry 1, and everything beneath that 0. I made top left 1 and everything beneath that 0. Now I look at the second, go to the second row, you always travel along the diagonal. So make this item or this entry 1. So how do I do that? That's an easy operation.
Multiply by the opposite.
Multiply by the negative opposite, not opposite, reciprocal. That's what you meant.
Yeah, the reciprocal.
Multiply by the reciprocal. So it's going to be -2/23 times row 2 becomes your new row 2. So let's go ahead and work on it. 1, 3/2, 1, right? And then -2/23 times 0 is going to be 0. -2/23 times -23/2 is 1. Okay. -2/23 times -2 is +4/23. So you got a 1 here. Now what you want to do is take this one, consider this one, and above that you have a number, you want to make it a 0, so that you have 1, 1, 0, 0, 1. How do you do that? Pretty easy. Take the second row, row number 2, multiply it by -3/2, and add that result to row 1, and this becomes your new row 1. So row 2 doesn't change, keep in mind. Is 0, 1, 4/23. It stays as it is, only row 1 changes. So what is the operation? I take row 2, 0, 1, 4/23, and multiply it by -3/2. That's going to give me 0, -3/2. Then -3 times 4/23 is going to be -6/23. Did I do it right? Yeah, 0, 2 cancel out. Yeah, -6/23. With that, I'm going to add the first row, which is going to be 1, 3/2, and 1. Okay. So 1, 3/2, and 1. Hold on 1 second, guys. Okay, so if I add these numbers, rows, I get 1, 0, and -6/23 plus 1. So it's going to be 1, 0. So -6/23 plus 1. 1 is 23/23. That's going to give you 17/23. So it's going to be 17/23. So your first row becomes 1, 0, 17/23. Okay, now we are done. Because look, this is my X column, this is my Y column, and this is my constant column, right? Then what we have is this. The first row tells me that 1 times x plus 0 times y is equal to 17 over 23, right? Or x is equal to 17 over 23. In our case, it's not x, but rather a, right? A is equal to 17 over 23 because we used a instead of x and b instead of y. So let's cross this out. And the second row tells you 0 times a plus 1 times b is equal to 4 over 23, right? That tells me b is equal to 4 over 23. And this is exactly what we have got in the other problem. Is this clear to everybody?
Yes.
Yes.
For sure.
Yeah.
Okay, let's check it. What I'm gonna do, I'm gonna give you the other problem that I gave you in the homework, which is this: 4x minus 1 divided by 5x plus 3 times 2x plus 1. I want you to do partial fraction of this, find the values of a and b, right? And solve the equation that you will get, system of equations, by using Gauss-Jordan method. Solve the system of equations using the Gauss-Jordan method, not the elimination method or substitution method, but rather Gauss-Jordan method. So everybody do it, okay? I'll give you a few minutes to work on it. Anybody has answer? Anyone else? Brandon?
I'm not finished yet, but I'm on the fourth part of the Gauss-Jordan method.
You need a little bit more time?
Yeah, maybe like
2 minutes?
Yeah.
Okay, I'll give 2 more minutes.
All right.
First, a over 5x plus 3 plus b over 2x plus 1. Okay. Now let's go ahead and do the multiplication. By now you know how to do the multiplication, right? So I multiply both top and both sides of the equation by 5x plus 3 times 2x minus 2x plus 1. So 5x plus 3, 2x plus 1. Let's do here on the left, 5x plus 3 times 2x plus 1, and 5x plus 3 times 2x plus 1. These cancel out. That gives you 4x minus 1 on the left, and on the right 5x plus 3, 5x 3 plus 3 cancel out. Then a times 2x is 2a x, then a times 1 is a. Similarly over here, these cancel out. That gives you 5bx plus 3b. So 4x minus 1 is equal to 2a plus 5b times x. I factored out x between the two there, then plus a plus 3b. Now I kind of compare the coefficients. So on the left, x has a coefficient of 4. On the right, x has a coefficient of 2a plus 5b. So 2a plus 5b is equal to 4. Okay. 2a plus 5b is equal to 4. And on the left, constant is -1. And on the right, constant is a plus 3b. So a plus 3b is equal to 1. Oh, sorry, not 1, -1. -1. So I'm going to use the Gauss-Jordan method. So 2, so my a, my b, my constant. All right. A is 2, B is 5, and C constant is 4. Coefficient of A, that's what I meant. Coefficient of A is 1, coefficient of B is 3 in the second equation, and constant is -1. This is my augmented matrix. Now I'm gonna follow the row operations. So let's go ahead and do that. All right. Now this one is easy kind of. I'm gonna switch row 1 and row 2. Row 1 and row 2. That's gonna give me a 1 here, right? So it's gonna be 1, 3, -1, 2, 5, and 4. Easy. I just had to switch 2 rows. I'm done. Okay. Next, I gotta make this number 0 under the 1. So take the, my operation is gonna be -2 times row 1 plus row 2 becomes my new row 2. So let's do it here on the bottom. -2 times row 1. So it's going to be 1, 3, -1. I multiply it by -2. That's going to give me -2, -6, 2. And take that result and add it to row 2, which is 2, 5, and 4. There's going to be 0, -1, 6. This turned out to be really nice. That's kind of funny. So it's going to be 1, 3, -1, 0, -1, and 6. Now I just have to make this a -1, a 1. So I just take -1 times row 2 becomes my new row 2. Easy. First row I don't touch. 1, 3, -1. Then 0, 1, -6. Very simple. Now I gotta make this a 1. Easy. -3 times row 2 becomes your new row 2. All right. So row, oh, sorry, I made a mistake. -3 times row 2 plus row 1 becomes my new row 1, right? So -3 times row 2, -3 times row 2 is 0, 1, -6. So that's going to give me 0, -3, 18 positive. With that, I add row 1, which is 1, 3, -1, and that's going to give me 1, 0, 17. So it's going to be 1, 0, 17, and then 0, 1, -6. And that, by the way, gives you the following: A, B, and constant. So the first equation tells you 1 times A plus 0 times B is equal to 17, or A is equal to 17. The second row, this is the first row. The second row tells you 0 times A plus 1 times B is equal to -6, or B is equal to -6. So your partial fraction becomes, so let me write it in red so that you can see it clearly. 4x minus 1 divided by 5x plus 3 times 2x plus 1 is equal to a over 5x plus 3. A is 17. 17 over 5x plus 3 plus b is negative 6. So I'm just gonna make this negative, so that's easier. Okay, so instead of writing negative 6, I'm gonna make it negative 6 over 2x plus 1. That's it. I think Michael got that answer. Michael, did you get that answer?
Yeah, I got that answer.
Okay, see, so now we kind of killed two birds with one stone. We did partial fraction, and in the process, we learned about Gauss-Jordan method as well. All right, I think I have given you sufficient example. Do you guys feel confident enough to the point that you can go ahead and do it on your own?
I feel pretty good.
How about others? Yes.
Yes.
Okay. So I'm gonna stop working on these two things here, and I'll probably give you some homework on this. So look for it tomorrow sometime, involving partial fraction and Gauss-Jordan method, all right? And some of the other topics that I have covered. Now,
Me enamoré de los mensajes bonitos, de cómo está mi amor, de cómo amaneciste. Yo solté todo para ponerme para ti. Tú eres media celosa, te quiero así. Yo soy.
okay, there's good music going on back there. Now I'm gonna introduce a new rule, new topic, which is also a rule. It's called Cramers rule. It's called Cramers rule. What is a Cramers rule? Cramers rule involves solving a system of equations. Typically, I give the example with a system of 3 equations, but before I can do that, I kind of need to do something else that I did for a 2 by 2 matrix, but I did not do it for 3 by 3 matrix. I need to do it for 3 by 3 matrix. I have defined the determinant of a matrix, right? So let's say 2, 3, negative 1, 7. It's a 2 by 2 matrix, and the determinant of this matrix is gonna be, you multiply 2 and 7, 14, minus you multiply 3 and negative 1, that's gonna be negative 3. So it's gonna be 14 plus 3 is equal to 17. Or I could give you another example. Negative 1, 4, negative 2, 0, let's say. Again, the determinant of it is gonna be negative 1 times 0 is 0, minus 4 times negative 2 is gonna be 0 minus negative 8, which is 0 plus 8, just 8, right? So you get the idea for determinant. How about if I do this? 1, negative 1, 2, 0, 3, 4, 5, 1, 2. This is a 3 by 3 matrix, square matrix. I want you to find the determinant of it. Okay, you need to find the determinant of it. So please pay closer attention, and you will need to know how to find the determinant of a 3 by 3 matrix when you find the when you try to use Cramers rule to find solution to a system of linear equations. The way you do it is this. I'm kind of gonna give you this. So let's say this is the determinant of A11, A12, A13. Remember, this is how we identify the entries in a matrix by row and column. A21, A22, A23, A31, A32, A33. Do you see that? Now, A11 is this item or entry, A12 is this, A13 is 2. This is row number 1. So the first subscript gives you the row number and the second subscript gives you the column number. A21 is the row number 2, which is this number. A22 is this number. A23 is this number. A31 is this number, 5. A32 is 1. A33 is 2. It's just identifying the entries. It's just identifying the entries. All right. Now, let's go ahead and solve it. Find the determinant. The way you do it, you can expand and find the determinant along any row or along any column. Whenever you're doing it, you want to look for rows or columns with zeros. Because if you have any row or column with 0, it's an easy way to get rid of one of the terms. But let's go ahead and do it along the first row first, and then I'm going to do the same thing along the first column for you. So the first row is going to be, so you're going to consider the top left corner item, which is 1, right? 1. You write 1. Now, this is going to be positive sign. It's going to have a sign associated with it. It's positive sign because look at the subscripts, 1 and 1. So if you add the 1 and 1, 2. 2 is an even number, meaning that it's going to be a positive. Technically, what it is negative 1 to the power I plus j. That's what it is. I is the row number, j is the column number. So if I is 1, j is 1, then it's going to be negative 1 to the power 1 plus 1, which is negative 1 to the power 2, which is just 1. Then the next one is going to be negative 1 to the power I plus j times the actual number itself here, which is negative 1. Now look, this one is entry A12. Look at the subscripts, 1, 2. So it's going to be negative 1 to the power 1 plus 2 times negative 1. So negative 1 to the power 1 plus 2 is 3, right? Times negative 1. Negative 1 cube is negative 1 times negative 1. So this gives you positive 1. Similarly, the sign associated with 2 is going to be negative 1 to the power. So 2 is what? A13, right? A13. So it's going to be 1 plus 3 is going to be negative 1 to the power 4 times 2. But negative 1 to the power 4 is just 1, which is equal to 2. Now, let me pause here. Is everybody okay with the sign associated with each entry in the matrix, in this square matrix? What is the sign associated with 5? So let's say 5 times negative 1 to the power something, right? What would that be? Can anybody help me? What is the sign associated with 5? What is it? What is the sign associated with the number 5?
Is it A31?
Yeah, a sub 3, 1, right? So it's going to be 3 plus 1, right? So negative 1 to the power 4, which is just 1, right? So it's positive, right? So the signs are typically positive or negative. So let's go ahead and create a sign table here. So what is the sign associated with A11? Is it positive or negative? 1 plus 1 is?
Positive.
1 plus 1 is 2. It's an even number, right? So it's positive. What is the sign associated with A12? 1 plus 2 is 3. It's an odd number. So this should be what? Negative. Then what is the sign associated with A13? What is it? Guys, be proactive. Tell me.
Is it positive?
Yeah, it's positive because 1 plus 3 is 4. It's an even number, so it's positive. Now, be proactive or I'm going to call your name. So what about A21? What is the sign associated with it? Sign associated with it. Somebody else other than Michael. A21, what is the sign? Nayeli, what is the sign for A21?
Can you repeat the question, please?
What is the sign associated with A21?
I don't know.
Okay. Mariana, what is the sign associated with A21?
I'm not sure.
What is 2 plus 1?
3.
Is it an odd or even number?
Odd.
If it is odd, then it's minus. If it's even, it's plus. How about A22? Brandon, A22, what is the sign associated with it?
Positive.
Because 2 plus 2 is 4. How about A23? What is the sign associated with it? Somebody else. Lisbeth or Lizette, I think.
Negative.
Negative, because 3 plus 2 is 5, which is odd. How about A31? What is it? Positive or negative sign?
Positive.
Positive, because 3 plus 1 is 4. A32 is going to be negative, because 3 plus 2 is 5. Then A33, 3 plus 3 is 6, is even, is going to be positive. And that's how you do the sign. It's pretty easy. You start at the top left, positive, then alternate it. That's it. You're done. Positive, negative, positive. Then what? Come down, negative, positive, negative. Come down, positive, negative, positive. That's it. But I gave you the reasoning behind it instead of having you memorize it. Is the subscript, you add those two subscripts. If it is even, the sign is positive. If it's odd, the sign is negative. If it's even, the sign is positive. If it's odd, the sign is negative. Is this clear, everybody?
Yes, sir.
Yes.
Now, I lost track of my whole thing. I'll just erase it and make a new matrix that way. So 1, so make it, 1, negative 1, 2, 0, 3, 4, 5, 2, negative 1. I just made up this matrix 3 by 3, and we need to find the determinant of it. Okay, so determinant of it. So to find the determinant, you expand it either any row or any column. So I'm just going to do it along the first row. Okay, along the first row. So the top left is going to be positive. This is negative, and this is positive. You guys know it by now. positive, negative, and positive. So it's positive 1 times, take off the first column and take up the first row. Then you're left with just this. Do you see that? Take up this. So you're taking the top left corner. So corresponding to that entry in the matrix, there is a row and there is a column. Get rid of it. Just cross it out in your mind. Then you're left with this stuff in the box. Find the determinant of it. Okay. So what is the determinant gonna be? 3 times -1 is -3, right? Minus 4 times 2 is 8. Okay, that's what you will do. Is this clear to everybody?
Yes, sir.
Okay. Now, I'm gonna go to the next number in the row, which is what? -1, right? That's the number here. Actually, for clarification, let's make it -2. I'll tell you why. Make it -2, but it has a sign associated with it, right? So -2, that has a negative sign. So it's gonna be negative here, right? So negative times negative is gonna be positive, all right? Negative times negative is gonna be positive, all right? Then, so I'm gonna just erase this thing. So this is gonna be +2 times, again, take off this column and this row. Then what are you left with? You're left with, let me put it in black, this, and this. You just do the determinant of those 4 items. 0 times -1 is gonna be 0, minus 4 times 5 is 20. Then the last one, let's use a different color. Let me use green, is 2. But the sign associated with it is positive. So you're gonna write down +2 times. Now exclude this column and this row. You always exclude the first row, and then since you're expanding along the row, and then you go through the columns. So if you get rid of those, you're left with this. What is the determinant of this? 0 times 2 is 0, minus 5 times 3 is 15. And that is how you will do it. Okay, so that becomes 1 times -3 minus 8 is -11, or -11, plus 2 times -20 is -40, plus 2 times -15 is -30. So -40, -30, -70, minus 11, -81. So determinant of this is -81. Now I'll give you a couple of minutes only to take the same matrix, okay? 1, -2, 2, 0, 5, 3, 2, 4, -1. The same matrix, square matrix. This time, however, you don't expand it along the first row, but rather expand it along the first column. Everybody, go ahead and do it. I'll give you a couple of minutes. I made it even easier. The second term, there is a 0 here, right? There is a 0 here. That's gonna kill one of the terms. That's gonna kill this middle term, okay? The middle term is gonna be killed, because if this number were to be 0, it didn't matter what were there, it'll be 0, right? So expand it along the first column. You could expand it along the second column, third column, or second row, third row, it doesn't matter. You should always get -81, given that I haven't made a mistake in this calculation here. So go ahead and do it, everybody. Expand this along the first column. So we are looking to find the determinant of the same matrix, right? All right. Go ahead and work on it. Okay, guys, did you get the determinant, everybody? Everyone got it?
I believe so.
Huh? I can't hear you, sorry.
I think so.
Okay, did you get negative 81?
Yeah.
Yeah. Okay,
I was stretching.
all right. So let's try it. I'm gonna do it. So 1, is it gonna have positive or negative sign?
Positive.
Positive. So if I take away the first row and first column, I'll be left with this portion only, right? So it's gonna give me negative 3 minus 4 times 2 is 8. Then plus 0. Sorry, not plus, minus. It doesn't matter really, even though it's minus, but 0 times whatever is gonna be 0, right? And the last one is 5. So take off this row and this column, you'll be left with negative 2 times 4 is negative 8, minus 3 times 2 is 6. So it's gonna be negative 11 plus or minus, doesn't matter really. Actually, I'll just ignore the middle term is 0, right? So plus 5 times negative 14 is gonna give you negative 11 minus 70 is negative 81. Now you have an idea how to find the determinant for a 3 by 3 matrix. Okay. How to find the determinant for a 3 by 3 matrix. Now let's go ahead and do the Cramers rule. First, I'm going to create a set of system of linear equations. So let's say 2x minus y plus 2z is equal to 6. X minus 3y plus z is equal to negative 2. 4x plus 2y minus z is equal to 5. Okay, so this is my system of linear equations, and I want to solve it. So what I'm gonna do, I'm gonna create the augmented matrix first, even though I'm not gonna really do the Gauss-Jordan method. Augmented matrix is gonna be x's, y's, and z's, and the constant. 2, negative 1, 2. I'm taking the coefficients of x, y, and z for each of these equations. 1, negative 3, 1, 4, 2, and negative 1, and the constants are 6, negative 2, and 5. So consider this matrix only, I call it D. Okay? I call this matrix D. Then look at the first column, 2, 1, 4, the x column. I'm going to replace it by 6, negative 2, 5, negative 1, negative 3, 2, 2, 1, negative 1. Do you see what I did here, everybody?
Yeah.
Lizette, do you see what I have done here?
Yes.
Can you tell me what I did? What did I do?
It's the first the 2x minus y plus
What I did is I replaced the first column by this constant. Do you see? 6, -2, and 5. And I call it d sub x because I got it from first column by replacing the first column. Now I'm going to replace the second column by these numbers, and I'm going to call it d sub y. So my d sub y is going to be this 2, 1, 4, 6, -2, 5. So this is the column I replaced. Other than that, everything is okay. 2, 1, -1. There you go. Technically, there is a little bit of notational issue here, but I will tell you what it is. And finally, d sub z. Okay. D sub z is going to be, I'm going to be replacing the third column. So 2, 1, 4, the first column, fine. -1, -3, 2. Now this third column will be replaced by this 6, -2, and 5. Okay, and my d was the first one, 2, -1, 2, 1, -3, 1, 4, 2, and -1. All right. Now you know how to construct d sub x, d sub y, and d sub z, and the d. But only notational difference is this. Let me just tell you, okay? D sub x is actually the determinant of this matrix. D sub y is the determinant of this matrix. D sub z is the determinant of this matrix, okay? And D is the determinant of this matrix. Okay. Now, is this clear to everybody? The determinant. So, how you construct these determinant matrices for which you find the determinant?
Yes, you're just rotating the constants.
Yeah. So, your solution to this system of equations, x is going to be d sub x over d. That means the determinant you get here, you divide this divide by this determinant. Your y is going to be d sub y over d, and your z is going to be d sub z over d, and that's how you find this. So now I'm going to give you a homework. I have shown you how to find the determinants, okay, for 3 by 3 matrix, and I have told you what is the Cramers rule, and I have shown you how to create the different matrices. You actually go ahead and calculate each of these determinants, all 4 of them, and find the solution to this system of equations, x, y, and z. So you need to find x, comma, y, comma, z. What are these values? It's going to be a, b, and c. What is a, what is b, and what is c? In the next class, I'm going to go ahead and ask you, everybody, please work on it. I'm going to ask you individually what you got for each of these answers and how you found it. Is this clear to everybody?
You mean you're going to give us new homework that's going to have these types of questions, right? Not these ones exactly.
Yes. And on the final, you'll have questions like this. So I want you to do this particular problem and bring it to the class on Monday. Is this clear? Everybody, is it okay? Yes, no?
Yes.
Okay. Okay, so make sure that you do this particular problem and give me the solution on Monday, the values of A, B, and C. All right, that's all for the day. Thank you very much.